Okay, let's move ahead now. We will see how can we aggregate data using group functions. Okay, now what are group functions? So we learned a single row query, multiple row query, right? The single row query we are already done, where we used to get a single row. We used to do some function on the row and give an output, which is also single row output. Now these are multi-row output, where what we do is we aggregate the data, okay, and then we try to produce a single output. Okay, so these are group functions. The group functions operate on sets of rows to give one result per group. Okay, so we group our data in the, like whichever whatever group we want, and then after grouping we can do some or make some analysis on data, or make some or give some output. So for example, you can do a sum, you can do an average. Okay, many things you can do. Let's see what are the things we have. We have average, count, max, min, standard deviation, sum, variance. We can do many things here. Okay, so how do we write group functions? So normal select and then the column. Okay, then we can have multiple columns here. Then group function. Okay, and also this column is optional. So if you want do a group function on all the rows, you can just exclude this column. Okay, otherwise this column creates a window. Okay, then group function on some other column from a table, where you can have a where condition if you want. Group by mandatory again if you have a group function. So this column will come here, and order by the column that you want to order by. Okay, let's see. Creating groups of data. If you see here, employees. So if I do a group by department ID, what's happening actually is this is the data, right? So for the 10 department, I only have one person, right? So 4400 is what comes here. Now for 20, if you see, I have two departments. So 1300, 13,000 and 6,000. Now the average of these two is 9500. Now this is what we are getting here. Okay, next for 50. Okay, so 50 I have some 5 rows. So the average of these 5 rows is 3500, and that is what we get there. So this is how we do the group functions by a particular column. So in this case it is department ID, and we group the data based on a particular column and perform the function on the column on which is a numerical column. Also we can do a grouping by based on more than one column. So previously we only did for department ID. What we can also do is in each department ID there can be multiple job IDs, right? If you see for 50, earlier we had 550s, right? Now also we have 5, but then now four of the 4 out of the 5 rows for department ID 50 is ST clerk, whereas one of them is ST man. Now what happens is if you do a group by of department ID and job ID, where department ID come first, so you will have it this way. So 50 for ST clerk, and when it's 50 for ST clerk, this rows gets summed, and then you get the data 50 row for ST clerk 11700, and 50 of ST man. 50 of ST man, again it is same. So it is only one. So because so it will be same. So 5000. Right, let's see how can we write these queries. Okay, so salary is a column in which we can do whatever we want. Average of salary, sum of salary. So here we are not putting any grouping columns. We just want in the overall data what is the min, what is the max to understand the data, right? We do this kind of checks generally when we get new data. So you see average of salary is 6461. Okay. What do we do if we don't want all this? We can round off it if you remember. So nesting of functions, you remember we learned nesting of functions. So I write average of salary in between round, and it's okay. I just put for 2. Okay. Oh, now this looks good, right? Then we have sum of salary. Then that means total salary being spent on my employees is this much. The minimum salary someone is getting is 2100, where the maximum salary someone is getting is 24,000, right? Now let's see the one which we were getting there. Department ID, comma sum of salary. Okay, group by department ID. Okay, so what I did is I grouped by department ID. So for 50 total salary is this much, 40 is this much. Now if I have job ID, also I can just include department ID, comma job ID. Remember this is mandatory. Okay, whatever you're not grouping, that column should come here. Okay. Okay, next thing. What if we want to put a filter condition on my grouped function? For example, in sum of salary, I only want those departments where the sum of the salary is greater than 10,000. Okay, so what I do, group by, then having sum of salary greater than 10,000. Remember, whenever you're doing a group by, you can't use a where clause. See, you can use a where clause. For example, here, where department ID is equal to maybe or maybe department ID is equal to maybe what, 50, say 50. Okay, you can do this thing. Okay, you can do this kind of where clause. So group by will come then after where clause, but you can't put this kind of filters, okay, in where clause, because this is a new new column itself, which is new, or a new expression which is being built here. So that goes into having. Okay, so having sum of salary greater than 10,000. Okay, always remember this. And then if you want, you can order. Okay, order your data, order by job ID. So if you remember, we had discussed that order by always comes as the last clause of a query. Just put it for descending. Okay, now we see. Okay, so we learned how can we do grouping. Okay, you can try this. You can try the same thing using various other grouping functions on your own. What you can also do is you can nest. Okay, your queries. Okay, you can also do that. Now let's see some other things in grouping. Okay, you remember we did a count. Okay, so there is something called as count in SQL. So let's have a count of department ID. Is it correct? Okay, 106, which means there are 106 rows in my employees table. If I would have done this in any other column, I would have got the same data. Let's see what I would have got if I did on a null column. Where I get 30 or 35, which means there are 35 rows in the table which in which the commission percentage has got some value, right? Now let's go back to the previous one, department ID. So we got this as 106, right? But actually this is not correct, right? Because department ID, we it's repeated. Now what I do is, in case I put distinct here, I get 11, which means there are 11 distinct values of department ID in my column department ID of HR.employees. Okay. Okay. Moving ahead. Subqueries. Now, this is also a very interesting concept. So, using a subquery to solve a problem. Who has a salary greater than able? So for example, I know what is able salary and I want to find who has salary greater than able. One way is, first I find out with a query that, okay, select salary from employee where last name is equal to able, right? We can do that. But why? And then we get the salary and then we hard code. So select star from age dot employees where salary is greater than the salary we just now got. We can hard code the salary, but that is not how it should be, because able salary can change over time, right? So for that we need to use a subquery. Let's see the syntax first. Okay, the subquery or the inner query executes once before the main query, right? The result of a subquery is used by the main query. Okay, this is the subquery. It is used by the main query. Okay, so select list from table where the expression, this is the operator which is equal to or in or greater than or less than. Okay, and then we have a list. So first this executes. Okay, first this is executes and then we get it. Now types of subquery, there are two. Okay, one is single row subquery which just returns one row, okay, or just one value. There can be multiple row subqueries where we get multiple values. Okay, we get multiple values. So if you remember, what do we use for multiple values? If we have a list of multiple values and I want whatever filter I'm putting, it should be in either of the values, then it's fine. We use in clause, if you remember. So single row subqueries, it returns only one row. Use single row comparison. Okay, let's have a look into executing single row subqueries. Okay, so what are we doing here is select last name, job ID, salary from employees, where job ID is equal to select job ID from employees where employee ID is 141. Now, I am very much sure that, okay, 141 can occur only one time, once in my complete database. So obviously I'll get only one value out of this query, job ID, which is ST clerk. So I can have a single row subquery, which is equal to. So ST clerk, and salary greater than, select salary for employees where employee ID is equal to 143. Now also I am again sure that because employee ID is a unique column or a primary key, so I know only one value will be returned from here, right, which is 2600, and I can very easily use a greater than operator, which is again a single row operator, right, because we can't have multiple options on this end like 2600, 2700, right? We can't have it a greater, so we can use this. What we can also do is to, if you want for a single row subquery, we can use group functions. Okay, so when you group function without a column here, okay, on an overall group, you get a single value for sure, right? Minimum salary, you get a single salary. So here in this one, the question was get the data of the lowest paid employee. So what we did is, we can write salary is equal to minimum of salary, right? So what we did this instead, where salary is equal to select minimum salary from employees. Okay, now multiple row subqueries. Okay, what is multiple row subqueries? It returns more than one row, and we use multiple row comparison operators. Okay, so here we have multiple. We have in, we have any, we have all. Okay, we have in, any, and all. Let's actually run through them. Okay, let's run the queries. So select last name, comma, job ID from employees where job ID is equal to, select job ID from employees where, okay, where employee ID is equal to 141. Okay, so what I did, I selected all the employees who are working in the same job ID of the employee 141. So from this, I took the job ID of the employee ID 141, and that is the job ID equated here. Okay, this was the question. This is again a single row query. Okay. Um, we will quickly see how can we use this subquery in a having clause. Okay, so let's do that. Let's have job ID and average of salary from HR employees. Fine. Group by job ID. So what I just did is I am selecting first. Let's see this. What I'm doing. I'm taking the minimum salary from HR employees where the department ID is equal to 50. So basically, I'm taking the minimum salary of department ID 50, and I am seeing for all the job IDs where the average salary is greater than the minimum salary, okay, of the department ID 50, 19 rows, right? This is how you can use a subquery in the having clause as well. Always remember, even if it's a subquery, even if it's a filter, whatever it is, if you are using your grouped function column, you can't use it in a where clause. Always remember that. Okay. Next, we will see the multiple row subqueries. Okay. Hmm. So what do we have here? Select last name, salary department. Okay, so what did we do here? Let's first see what question it caters to. What we're actually doing is first we're selecting all the minimum salary of each department. Okay, we are selecting the minimum salary of each department. After getting that, we are using those salary as a list, and this salary, whatever we are using here, this salary should be in any of the values we are getting from this list, right? That is why we have in. So instead of hard coding the values, we are just using a query which is more better, and it is more dynamic, right? Sometimes we need to hard code values, yeah, that's fine, but then writing this kind of queries makes your query more dynamic, and wherever possible we should be using this type of queries. Okay, so this was in. Okay, next what we will see is any. Okay, so now what is any? Let's check that out. What happened? Okay, check out employees. Okay, so what happened here is first we are selecting all the salaries, okay, from of the employees who work in IT program job ID, right? Now, what does any means? Let's see how many data are we getting here. We're getting 80 rows. And what if we do all? How many are we getting? We get 44 rows, okay? Now, what is the difference? See, hmm. So any is, okay? So if I write any, mm, mm, mm. if I write any, it means if I have three values, just think this data is returning me results, which is maybe 3,000, 4,000, and 5,000, for example. Okay, just imagine this is returning me data IT programming. The salaries in IT programming is 3,000, 4,000, 5,000. There are three people. I'm just assuming it for now. Now, when I say any, it means if the salary is less than any of them, okay, then it's fine. I'll take it, which means the highest here is 5,000, right? So if I get a salary here, which is 4,500, that will be included in this result because it is less than any of them, right? 5,000 and the highest is 5,000. If there is a salary which is less than 5,000 in any of them, okay, we should get it. We are not comparing with each and every one of them. Okay, this is any. Now all. Now what is the use of all now? It means only if the salary is less than all of the salaries, which means the lowest is 3,000 here, right? So only if a salary which is less than the 3,000 value is, then when we get the row returned. That means 4,500 salary will not be returned when we are using all. Okay, only salaries which less than 3,000 is what will get returned. Remember this. All means this value should satisfy all the rows that we are getting. Any means if the conditions are satisfied with any of the value, then we are fine with it, right? So that is the difference between any and all. Okay. Okay. So okay, one last quick thing I want to show you. Okay. In Oracle, very specifically in Oracle, there is a table called as all tables. See, there are two kinds of tables which can happen. Okay, one is the system table, one is the user table. Now, system tables are tables which are created by the system and which contains the metadata about the system, right? System table contains the metadata about the system, or and the tables, right? So the details about the tables, okay, and details about other tables and everything is stored in table all tables. This is a metadata table. Okay, what is a metadata? It is data about your data, right? This we call. So now see, if we do a select star from all tables, right? So what do we get here? We get all the owner and we get the table name. Now let's just put here from all tables where table name is equal to employees. That is the table we used, right? Throughout the course. Okay. Let's do this. Let's keep it here and put it like this. Or let me just put where owner is equal to. Okay. Why it didn't come as, you remember okay, why it didn't come as I put everything in small. It should be in capital. Okay, let me just put it HR here. Okay, see employees, it's in capital. So if I put this employees in capital, okay, let me comment this and run now. Okay, so I get this. Now, what does this contain? Let me just comment this, and let's see if a few of the tables we have. So what does this contain? We have the owner. So you remember we were always doing HR dot employees, HR dot departments, because HR schema is the owner of this table employees or departments, right? That's why we were always writing HR. Without HR, our query wouldn't have understood where this employees is, because the same table employees can be there in multiple owners. Okay, so multiple schemas can have the same table. That's why we always had to specify which schema are we referring to, or which owner are we referring to. Okay, so we have owner, we have table. Okay, we have table space, and then we have various data about tables, right? Now this table is at the table level. So for each table we have one entry. We have another table with another system table, which is called all tab calls or all tab columns. Okay, both are the same. Okay, all tab calls or all tab columns. Now what this will do is this is at the column level. Okay, so now if I comment this and just go for the employees table, I see all the columns for the employees. So for example, salary, the data type, and many other details about the column. So what is the length, what is the precision, what is the scale, okay, of the data, right? So we get everything here. Okay, so in this table we can see more about the tables. Okay, so you can use these tables at your own disposal. You can query these tables to know more about the columns. Okay, with this we end the course